let's take a look at some two-dimensional figure properties. First of all, we want to classify what a polygon is. A polygon is a closed figure with straight sides, known as segments. These segments intersect only at the endpoints. Now you'll read in the book some different phrasing of the definition, but that's exactly what it is. It's a closed figure, so it's not open, with straight sides, known as segments. So there's these straight sides, no curves, and these segments intersect only at the endpoints, meaning they don't cross over each other. Okay, so well, let's draw in a couple polygons. This would be an example of a polygon, like a plus sign or a cross, whoops, or this awkward looking thing, assuming that closed right at the end point there. So we have all straight sides, it is closed in, there's no extra, and the segments intersect only at the end points. This would be something where we would not have a polygon. It's intersecting not at the endpoints, they're crossing over each other. So you could say this was two separate polygons, this triangle and this triangle, but you can't say that they're one big one because it's crossing over itself. Another polygon might look something like this, obviously all straight sides, not curved as it comes out. We could do this all day. You could go make something crazy like that. So there's a whole assortment. We're going to focus on some of the common ones, which are like heptagons, hexagons, octagons, things like that. So these are some examples of polygons. As long as you have straight sides, segments intersecting only at the endpoints, and it's closed in, you're set. Then we go on to a regular polygon. A regular polygon is a polygon with all sides equal length and all angles equal measure. So for instance, if we have to look at a square, oops, all of the sides are exactly the same. So we can use tick marks to demonstrate that, and all of the angles are the same. They're all right angles. Okay, if we look at an equilateral triangle, all of our angles are the same, making it equiangular, and all of our sides are the same, which is why we called it equilateral. A stop sign is a common regular polygon. It is all of these angles are exactly the same, and all of the sides then are also the same. There we go. So this is our stop sign. And we could do this for any figure. You could have a 5-sided pentagon, like they have down in the Capitol. And these are all these are exactly the same. All the angles are the same. You could also have a 5-sided figure, 1, 2, 3, 4, 5. That's also a pentagon, but it's not a regular pentagon. That's the difference. All right, some other things that are not polygons. Something like that, maybe a smiley face. It's a circle. If we have something open like that, none of those are polygons. All right, let's move on. Some common ones just to have them understood. Pentagon is a 5-sided figure. We use 5 fingers when we write with a pen. So 5 sides to pentagon. Hexagon is a 6-sided figure. Hex has an X in it and 6 has an X in it. Heptagon is a 7-sided figure, octagon is an 8-sided figure, and then if we're just talking geometry algebra purposes, we might call something an n-gon, meaning it has n sides to it. And that's just for calculation purposes. Alright, vocabulary, concave and convex. A concave figure, if I draw a picture for you, it looks something like this. This is a concave figure, and it is because I can pick 2 points in my figure, and when I connect them, the connecting line ends up going outside of the figure itself. Now I can pick other 2 points that are going to stay inside, I know that. But I can pick if I can pick one pair of 2 points where the line intersecting goes outside of a figure, then it's concave. And I like to say that it's easy if we draw something similar to that one. This is like a cave, it like caves in, right? And a cave caves in, we know what a cave is. So it's easy to recognize hopefully, with a concave figure, and if there's anything that's jutting inward, it's concave. And the opposite would be convex. So that might be something like this. Everything's kind of like going out. There's no 2 points that I can choose that will ever go outside of the figure. They're always going to stay inside. That's convex, a triangle is convex, a square is convex. It's only when we start jutting things in. So another concave thing might be like that plus cross sign that we saw, because we could pick these 2 points and they go outside. Concave, and it has like a cave in. Now example 1, tell whether the figure is a polygon. If it is, classify it by whether it's concave or convex. This is not a polygon because it has curved sides, so no. This is a polygon, and because there's no inward going pieces, it's all protruding out. This is convex. Cave goes in, vex goes out. Letter C is not a polygon because it has curved sides. Okay, if we go on to the next page, we're just going to classify a few properties of squares, rectangles, and rhombuses, or rhombi. These are all quadrilaterals. A quadrilateral is a four-sided figure. Okay, any four-sided figure is known as a quadrilateral. So it's a specific kind of polygon. It's like we have polygon as our big area. Then a more specific kind is a quadrilateral, four sides. You might think of a quad that you ride to remember it as four. And then specific quadrilaterals include things like squares, rectangles, a rhombus, and it goes on and on and on. Okay? So let's identify first a few. A square, I think we all know what that is. It has four right angles and four sides that are exactly the same. The perimeter is just going to be, again, add up all the sides, or we could, because all the sides are the same, label this side, 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 side. Perimeter is side, plus side, plus side, plus side, or we could call it 4S. Or you could just remember add up all the sides, either one. The area is going to be length times width, which is length times width, but because we're calling each length and each width side, it's side times side, or side squared. The special features, all four-sided figures have 360 degrees in them. So the reasoning is we know that a triangle has 180 degrees, right? Now if we take another triangle and flip it and make a four-sided figure, we end up with 180 plus 180, or 360 degrees. Okay? Now a rectangle has four right angles like a square does. However, the opposite sides are the same. So this and this are the same, and this are the same. And notice I use tick marks to show that these opposite sides are the same. These two with having two tick marks, these two only having one. All squares are rectangles because all squares have four equal angles and four sides that match these requirements. But a rectangle is not a square because a square has to have all four sides the same. This doesn't have that. Okay. Now let's take a look at the perimeter. We can call this length and this width. So the perimeter would be add up all the sides, or you could do length plus width plus length plus width, which comes out to be 2L plus 2W. Or just add up all the sides. Either one, you're going to get the same thing. Area is just length times width. And the special features, again, we have 360 degrees. All right, the last one we're going to look at for right now is a rhombus. And a rhombus is a figure where all of the sides are equal, but the opposite angles are equal. So this angle is the same as this angle, and this angle, notice I use two slashes, is the same as that angle. So for instance, if we were to put measurements in it, this here, this angle might be 30 degrees, this angle might be 30 degrees. And then this angle here might be 150 degrees, and this angle here might be 150 degrees, something like that. And then all the sides would be the same, so all the sides might be 10 inches, something along those lines. But the opposites angles are equal, and they total 360 degrees, so that's our special feature. 150 and 150 is 300, plus 30 and 30 is 360. The perimeter, all the sides are the same, so you could call them S in this case. Perimeter is going to be S plus S plus S plus S, or 4S. Again, perimeter though is always just add up all the sides. So it doesn't matter what you go to label them, just remember you're adding up all the sides.